Sorry for the break in transmission. This is video 13. I'm painting two scenarios here. The first scenario, three ladies went to fetch water from maybe from Obadam to their hostel in Namina or in Queens Hall. Now, the three ladies, the first scenario is that the three ladies will bend their head at the same time and pour the water into the drum at the same time. The second scenario is that they will do it one after the other. We are saying the two cases is such that the total quantity of water in the drum is going to be the same in the two cases. This is what superposition theorem is telling you. Either the sources, we are referring to sources of energy. If the sources of energy, let's say source 1, 2, 3, if they are all present in the circuit, the current they are going to jointly produce in say 4 ohm resistor is going to be the same current if each of them work alone while the others are not working. When you total the current produced by each of them working alone, is going to be equal to the total current to be produced when the three of them are working alone. So we are set to demonstrate this principle now. We have calculated the current in 3 ohm resistor with all the sources present. We now use superposition theorem. We are going to consider each source acting alone. Then there is something we do which you should always remember. When a source, like a voltage source, is not acting, we are going to short circuit it. What do you mean by short circuit? If it has been like this is a voltage source, we are going to replace it with a short circuit. That means you just join together. But you will still retain the internal resistance in it, in the circuit. But if a current source is not working, we are going to open circuit it. What do I mean by open circuit? We are going to remove it totally without bridging the gap. So if a voltage source is not working, we remove it and bridge the gap. That will short circuit it. If a current source is not working, we open circuit it, we remove it. So you will see as we go along. Now, so let us start by now practicing this circuit and then trying to solve the same problem, current in the 3 ohm resistor. Let's consider that we'll start by saying 9 volts acting alone. If 9 volts is acting alone, that means this will not be there. This source will not be there. It's a voltage source. What do we do to it? We bridge it. This is a current source. It is not acting. We want only 9 volts to act. We are going to open it. When we open it, the implication is that no current will pass through this 1 ohm resistor again, since that is open. So, but current will still pass through this 2 ohm resistor because this is closed. So this is our first circuit. You are giving the circuit you are given before, you have drawn it. We are going to draw another circuit such that 9 volts is acting alone. So we have removed the 7 volts, we short circuited it, we removed the 5 ampere source, we open circuited it. Now, so let's solve this problem. So if you are solving it, you can use, if you like, let's be using mesh analysis to solve this. If you are using, let's say this is mesh 1, I1, this is mesh 2, I2. You can use one method inside another method. It is allowed. So let me use mesh. So this is I1, this is I2, this is I3. Now, so from here, if you write KVL for this, 9 volts, 9 will be equal to, this 9 will be positive because this direction of the EMF and is in line with that direction is going to be equal to what? 3I1 plus 4I1. You know, I1 is going down, I2 is going up. This will be I1 minus I2. Hello, I1 in this 4 ohm will be going down, whereas I2 will be going up. So it's going to be I1 minus I2. So from here, I can say that 9 equals 7I1 minus 4I2. Take note of that. Then let me write KVL for the second mesh. KVL for the second mesh, there is no EMF in that loop, so that's going to be 0. And then I have 2 ohm. The current there is I2. I have 6 ohm. The current there is I2. I have 5 ohm. The current there is I2. You know, I2 is going this way. I3 is also going that way. That will be I2 plus I3. And then I have plus 4. I2 is taking current up. I1 is taking current down. That will be I2 minus I1. You can see that here we said I1 minus I2 because we are in this mesh. And I1 is taken to be positive. So I2 we have no choice but to be taken to be negative. But here, because we are in this mesh, I2 is the positive. So, and since I1 is running contrary to it, I1 is going to be minus.
5 ohm.
I what?
5 ohm resistance. The I3.
I2 is coming this way. I3 is going like that. That's correct.
I3 is.
Don't talk again.
So
They're not supposed to be here. I2 will go like this. I3, see the sign of I3. I3 will go like that. So I2 is going like this. I3 is going like that. So they are opposite. That's going to be I2 minus I.
that's for 5.
Okay, I wrote plus, Abi.
Yes.
Thank you. Sorry. I2 minus I3. That should be I2 minus. Thank you very much. It's good. Your intervention is good. Keep doing it like that. Thank you. Now, let's combine like terms together. Let's combine the like terms together. Do we have I1 there? I have 0 equals minus 4I1. For I2, I have 2 plus 6. That's 8 plus 5. That's 13 plus 4. That's 17. Plus 17 I2. For the I3, I have minus 5 I3. Minus 5 I3. And then the last one, if I take that loop, 5, that's going to be I3 minus I2. Then I3 minus I2 plus 1 ohm, the current through it is just I3. It's only I3 that will pass through that. So I3 minus I2, so from here equals 0. So from here we can see that 5 minus 5I2 minus 5I2 plus 6I3 equals 0. That will be what? I can say 0I1. Since I1 is not present there, I can say 0I1. So here I can say plus 0I3. So I can reduce it to matrix form. So this will be like 9. This will be 7. This will be minus 4. This will be 0. For the next equation, this will be 0. This will be minus 4. This will be 17. And this will be minus 5. For the last one, this will be 0. This will be 0, minus 5, and 6. This is like that. This is like that. And this will be what? I1, I2, I3. So my all I need is, you see, we are interested in the current in the 3 ohm resistor. So I need I1. So my I1 will simply be, you take this, this will be 7 minus 4, 0, minus 4, 17, minus 5, 0, minus 5, 6, and on top here, I'm going to replace the first column with 9, 0, 0, minus 4, 0, 17, minus 5, minus 5, 6. For a clearer view, let me make it separated. This will be minus 4, 0, 17, minus 5, minus 5, 6. Let's pause the video so that we calculate it and return the result.